However, we physicists say that the universe was created in a Big Bang 13.7 billion years ago, but then the question is, why did it bang? What set off the bang? For as long as we've been studying science and the history of our universe, the Big Bang has been the explanation for it all. There have been hundreds of studies and thousands of scientists have worked on the research, and from what data has shown, the Big Bang has been the leading theory that explains how the universe was made. That energy is dark energy, an energy source even bigger than galactic energy. Dark energy is the anti-gravitational force that's creating the expanding universe. But science today is a lot different than what it was back in the day, and with technological improvements come new theories. More often than not, we find out that things we believe to be 100% true are far from it. And well, it might have just happened again. Michio Kaku is finally talking about it. The Big Bang has officially been debunked, as the James Webb Telescope has detected 750 new galaxies, and they're nothing like what they should be. Join us as we delve deeper into what the James Webb Telescope found and how it changes everything we thought about the way the universe came into being. At first glance, the images of the new galaxies taken by the JWST look absolutely breathtaking in a good way. You can see hundreds of galaxies all in the same frame, and the sheer power in the photos is something you just can't ignore. But that's what things look like to the average person. For researchers, things are the total opposite. These pictures are surprising, to say the least. They don't match what scientists thought they would see based on their theories. In fact, they're seeing way more galaxies than expected, and these galaxies are different in some surprising ways. They're smooth, smaller than imagined, and really old. All these surprises are causing a bit of a panic among the scientists. One paper even starts with the word panic in its title, so you know things are serious. The galaxies look nothing like what they're supposed to. Scientists have put forward the Big Bang theory as the leading explanation for the origins of our vast universe. According to this theory, around 14 billion years ago, the universe came into existence through some sort of mysterious cosmic event. It's the ultimate birth story of the cosmos. The surprising nature of the images captured by the James Webb Space Telescope has challenged scientists' understanding of the universe's origins. The hypothesis that these images directly contradict is the Big Bang hypothesis, which has long been regarded as an unquestionable truth by the majority of cosmological theorists. These galaxies appear to be too small, too smooth, too old, and too numerous when compared to the predictions of the Big Bang hypothesis. The small size of the observed galaxies entirely contradicts the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger with increasing distance. Yet the JWST images show galaxies that are 2 to 3 times smaller than similar galaxies observed using the Hubble Space Telescope. This discrepancy challenges the notion of an expanding universe. Our universe isn't expanding into some pre-existing container. There's also the fact that the smoothness of these galaxies is totally unexpected. The Big Bang theory suggests that galaxies should exhibit irregularities and variations in their structures due to the dynamics of their formation and evolution. However, the JWST images reveal galaxies that appear unusually smooth, lacking the expected level of complexity and roughness, which is what you'd normally expect to see in the images. The age of the observed galaxies also seems incredibly strange. The JWST observations indicate the presence of galaxies that appear to be unexpectedly old. This challenges the expected timeline of galaxy formation and evolution within the framework of the Big Bang theory. Plus, there is also the fact that the abundance of observed galaxies is a lot higher than what it was supposed to be. The Big Bang hypothesis predicts a certain distribution and density of galaxies based on the expansion and evolution of the universe, but the JWST images show a massive number of galaxies, which raises questions about the accuracy of the predictions made by the hypothesis. According to the Big Bang theory, at the very beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into an extremely tiny and highly concentrated point. This point is called a singularity, a point where infinite density exists. When we say infinite density, we mean that the matter and energy within this singularity were squeezed together to such an extent that their density reached an infinitely high value. The concept of a singularity comes from our current understanding of the laws of physics, particularly the equations of general relativity proposed by Albert Einstein. Within the singularity, all the matter and energy in the universe existed in an extraordinarily compressed form. The extreme density implies that an enormous amount of mass and energy was concentrated within an infinitesimally small space. While the space isn't much of a problem here, when there's so much pressure and density, you've got unimaginable heat. The temperature within the singularity would exceed any temperature that can be observed or reproduced in our current understanding of the universe. The energy stored within this hot, dense point was the seed from which the entire universe would unfold. That's why the singularity marked the beginning of the universe as we know it. It was the origin from which everything in our cosmos came. After the initial singularity, the universe started the journey of expansion and inflation. This process occurred over the course of approximately 13.7 billion years, shaping the universe as we know it today. The expansion of the universe started with an extraordinary burst of rapid expansion, known as cosmic inflation. During this phase, the universe expanded at an unimaginable rate, far exceeding the speed of light. It's like the fabric of space itself was stretching and stretching, taking everything within it along for the ride. Cosmic inflation played a massive role in shaping the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and set the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed down. But with this information, it's important to note that even though the initial period of cosmic inflation ended, the universe continued to expand at a measurable rate. This ongoing expansion is known as the expansion of the universe or cosmic expansion. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. The redshift indicates that as the universe expands, light waves get stretched and shifted towards longer wavelengths, shifting them towards the red end of the spectrum. While the expansion was happening, we basically had all the stuff that makes up our universe squeezed into an incredibly small volume. It was clear that matter cannot survive in space like this, so something had to give. As the universe expanded and cooled down, transformations took place. Particles such as protons, neutrons, and electrons began to interact with light and energy in their surroundings. These interactions played a pivotal role in shaping the formation of matter in the universe. During the first few minutes after the Big Bang, there was a process called nucleosynthesis. This process involved the creation of lightweight elements like hydrogen and helium. The extreme temperatures and conditions during this phase allowed for the fusion of protons and neutrons to form these simple atomic building blocks. Hydrogen, the simplest and most abundant element in the universe, was formed primarily during this early period. Helium, the second most abundant element, also emerged during this time. These elements were instrumental in setting the stage for the formation of stars, galaxies, and more complex elements that would come later in cosmic history. The synthesis of these elemental building blocks was a significant milestone in the evolution of the universe. From a primordial sea of particles and energy, the early universe transitioned into a state where matter actually began to take shape. This process laid the foundation for the rich diversity of matter and the vast cosmic structures that eventually came into being. Now, the Big Bang Theory might seem like wordplay, but it is supported by a lot of compelling evidence. The Big Bang was an interesting event, but not the first event in the totality of reality. One of the most significant pieces of evidence for the Big Bang Theory is the discovery of the cosmic microwave background, CMB. The CMB is a faint radiation that fills the entire universe and represents the afterglow of the Big Bang. This cosmic radiation was first detected in 1965 and has since been studied extensively. The characteristics of the CMB align closely with the predictions made by the Big Bang Theory, providing strong confirmation of its validity. The observed pattern of the CMB radiation, including its uniformity and temperature distribution, supports the idea that the universe was once in an extremely hot and dense state before undergoing expansion. The presence of the CMB provides a remarkable glimpse into the early stages of the universe, serving as a direct echo of the initial moments following the Big Bang. Discovery and subsequent analysis of the CMB have played a crucial role in cementing the Big Bang Theory as the perfect explanation for the origins of the cosmos. In addition to the CMB, other lines of evidence further support the Big Bang Theory. You've got things like the observations of the redshift of light from distant galaxies that provide evidence of the expanding universe too. The observation that galaxies are moving away from one another in all directions suggests that the universe is continuously expanding, as predicted by the theory. The abundance of light elements such as hydrogen and helium found throughout the cosmos is also consistent with the predictions of the Big Bang theory. But not just that, the large-scale distribution of galaxies, which is something revealed through astronomical surveys, matches the predicted patterns emerging from the Big Bang theory. As astronomers have meticulously observed and mapped the cosmos, they have discovered a striking pattern. As scientists continue to analyze the data from the James Webb Space Telescope, the implications of these unexpected findings could lead to a complete overhaul of current cosmological models. The possibility of a new theory, one that might better explain the origin and structure of the universe, is an exciting prospect, though it also poses a challenge to our long-standing understanding of the cosmos. After all, the Big Bang theory has been the cornerstone of modern cosmology for decades, supported by an impressive body of evidence. Yet, as history has shown, science is always evolving, and what we consider to be truth today may be revised tomorrow. One of the key challenges moving forward is the interpretation of the data. The observations from the James Webb Telescope are not just anomalous. They are radically different from what current models of the universe predict. If these new galaxies are not what we expect, it could indicate that the assumptions on which the Big Bang theory is based, such as the expansion of the universe, the timeline of galaxy formation, and the uniformity of the cosmos, need to be reconsidered. As scientists pore over this data, they'll have to account for these discrepancies and work to develop a more comprehensive theory that better explains the structure and evolution of the universe. Additionally, the discovery of such an abundance of ancient galaxies could prompt a reassessment of the timeline of cosmic evolution. If these galaxies are indeed older than previously thought, this would challenge not only the Big Bang theory but also our understanding of the pace and process of cosmic growth. This raises the tantalizing possibility that the universe may have evolved in a far more complex way than we imagined, with multiple stages of development, some of which might have been missed by previous observational methods. Moreover, there's also the question of dark energy, which is currently understood as the force driving the acceleration of the universe's expansion. The James Webb findings could provide new insights into dark energy itself. Could the unexpected smoothness and size of these galaxies suggest that dark energy has had a different role in cosmic evolution than previously thought? Or could these new galaxies be signaling a different mechanism for cosmic expansion altogether? These are the questions that researchers will need to grapple with in the coming years as they continue to study the data from the telescope. One thing is certain: we are in the midst of a pivotal moment in cosmology. The discovery of these enigmatic galaxies has thrown open the doors to new possibilities and avenues of research. Just as the Hubble Space Telescope revolutionized our understanding of distant galaxies, the James Webb Space Telescope promises to transform our knowledge of the universe in profound ways. However, the shift from one theory to another is never simple, especially when a well-established idea like the Big Bang theory is involved. The process of scientific discovery is often messy, with new data complicating existing frameworks and forcing scientists to revise their models. As this exciting new era of astronomical discovery unfolds, the scientific community will no doubt continue to refine and expand our understanding of the cosmos. Whether the Big Bang theory will hold its ground or be replaced by a new theory of the universe's origins, only time will tell. But the implications of these findings will likely reshape our view of the universe in ways we can't yet fully comprehend. For now, the universe remains an enigma, and the James Webb Space Telescope has only scratched the surface of what is to come. As we delve deeper into the mysteries of the cosmos, we may be on the verge of uncovering truths that challenge the very foundations of modern science. This is the beauty of exploration. Whether through telescopes or theories, every new discovery brings us closer to understanding the nature of reality itself, and the journey of unraveling the mysteries of the universe is far from over. As we move forward, the integration of these new findings into our cosmological models will require not only technological advancements but also a shift in the theoretical framework that governs our understanding of the universe. One avenue of exploration could involve rethinking the role of dark matter in galaxy formation. Currently, dark matter is believed to be crucial for holding galaxies together, but the properties of these newly discovered galaxies might suggest that our understanding of this mysterious substance is incomplete. Could dark matter interact differently than previously thought? Or could there be alternative forms of matter at play that we haven't yet identified? Additionally, scientists may need to reconsider the process of galaxy formation itself. The current models, based largely on the Big Bang theory, suggest that galaxies form through a series of hierarchical mergers and accretions over time. But the unexpected size and smoothness of these galaxies could indicate that they evolved through a different mechanism, perhaps much faster or under different conditions than originally believed. Ultimately, this points to a fundamental question. Is our current understanding of time itself aligned with the nature of the universe? Perhaps time and space evolve in a more complex way than we imagined, calling for a deeper investigation into the very fabric of reality. As these new findings continue to unfold, they may open the door to an entirely new era of cosmological thought.